So the agenda today is, we're going to go into a little bit more about why do we want to simulate and look at the simulation packaging, how it relates to the demo that we're going to do today. And then we're going to look at our linkage that's animating right now. What are my worst case loads under multiple conditions? One of those conditions is going to be a harsh landing load. Another one of those is going to be normal operating cruising loads for our landing gear. There'll be dynamic shock loads that we're going to look at. And then misuse or abuse loads, where maybe our linkage is stuck and our actuators are applying full power. What's going to happen to our system when we do that? Do we permanently bend our system? And if we do, is it still going to be functional afterwards? So how much did we bend it? And after that, I'll open up the mute and we can get into Q&A and extra credit if there is somebody on the line that's interested in discussing hyperelastic materials. I do have a little bushing example that we can review afterwards, depending how much time is left. So why simulate? Well, it's just cheaper, less expensive, less time consuming to learn more about our designs early in the design process. It goes almost without saying that, once we get into creating prototypes, which are extremely expensive, or into production where we have to modify tooling, the cost of change is extremely expensive as time progresses. In addition, just looking at prototyping itself, we have a widget, and I really like this slide. It kind of summarizes the order of magnitude of cost differences and time differences. So we're going to go through 6 iterations and approximately 2 weeks of time and almost $11,000 in cost. We can do a quick comparison of what a virtual prototype can tell us, and we can get things done with easily 6 iterations in a couple days. And just looking at time as our costs, $1,600. So easily an order of magnitude cheaper and an order of magnitude less in time. Getting to market faster is almost as important as reducing your overall development costs. Virtual prototyping also has other benefits. When we create a simulation, we can extract data from anywhere in the model. When you do physical testing, we can only extract data where we put sensors or measurement tools. Just taking the data can actually affect our results. It's physically intrusive. In addition, long lead times, expensive equipment, and long setup and testing timeframes. The most common reason that customers come to me and want to talk about simulation is actually differentiation. They might be creating a commodity product and they want to differentiate themselves so they can increase their margins. And simulation is very often used to differentiate yourself and create new designs that you might not have extensive tribal knowledge. So from a packaging perspective, today is going to be a Simulation Professional and Simulation Premium. And we're going to start with motion and event-based motion. We're going to use this tool to figure out what are some of the forces in one of our linkages, and then move on to static analysis. Once we complete that static analysis, we want to see whether we're going to potentially bend the part or not permanently. And if we hadn't, then we want to see how many cycles we can survive at that loading. From there, if we check out, the next phase might be what can we do for mass reduction. So then we're going to take that stress analysis and run some optimization where we use the integration between SOLIDWORKS and simulation to automatically change the design and rerun different scenarios. After we're done with the optimization, we're going to move on to a couple different methods of testing our part. So one of the tools that we're going to use is linear dynamics. And we're going to use that for our random vibration loading. So that would be cruising loads or road loads if you're in a vehicle. Repeated, maybe the magnitude is not that high, but happening at different frequencies. Next, we're going to use a nonlinear dynamic simulation, and we're going to do an impulse loading. So maybe if we hit a really bad turbulence and our landing gear is stowed, we're going to see what kind of stresses are we imparting in our linkage with a shock type load. Next, we're going to overload, so we're going to assume that our linkage or our mechanism, in this case it's our landing gear, is stuck and the actuators are firing off a full load. So if the mechanism can't move and we fire up our actuators, are we going to get permanent deformation? And how much permanent deformation? And that falls into a nonlinear static load case.